Hello and welcome to a lesson on coordinate geometry basics. In this lesson we're going to look at straight line coordinate geometry. We'll begin by using autograph to look at some examples of straight lines, and then we'll look at the various properties and techniques you need to be familiar with to answer A-level questions on this topic. To begin then, here's the graph of y equals x. It doesn't get any more simple than that. It's a line of 45-degree slope passing through the origin. Y equals x. We say that has gradient 1, the number of x's we have in the equation. If we move on to look at one y equals 2x, we'll see that that's steeper. It basically means that y goes up 2 for every 1 increase in x. So when x goes from 0 to 1, y has gone from 0 to 2. When x has gone from 0 to 2, y has gone from 0 to 4. Now we look at y equals a half x or 0.5x, and we see that this time the slope is less than 45 degrees. Again, the gradient we say is a half. It's a measure of how much change you get in y for how much change in x. So when x goes up 2, y only goes up half as much, just 1. Now what about y equals 3x minus 2? The 3 is the gradient, tells us it's quite a steep line. The minus 2 is what we call the y-intercept. It's where it cuts the y-axis. Because if we put x is 0 in this equation, we get y equals 3 times 0 is 0 minus 2. And so that constant on the end will always tell you where a straight line cuts the y-axis. One final one, let's have a look at y equals minus x plus 1. Here we see that the line slopes the other way to all the others we've looked at. It doesn't slope from bottom left to top right, it lies backwards, it slopes top left to bottom right. And that's the minus sign in front of the x, it has a negative gradient. The plus 1, the constant on the end, still tells us where the line cuts the y-axis. Now then, let's move on and look at the general definition of the straight line. Y equals mx plus c. Mathematicians use the letter m to denote gradient. So y equals mx plus c is a straight line, gradient m, and passing through c on the y-axis. So having looked at a few lines, let's now look at properties of lines and techniques for finding equations of lines. First of all, what about the gradient of a line between two given points x1, y1 and x2, y2? I have a diagram here on which I've marked 2 points, x1, y1 and x2, y2, and I've joined them with a line. And I now want to find the gradient of that line. Well, the gradient is the change in y's divided by the change in x. So it's y2 minus y1, that gives us that distance there, divided by x2 minus x1, that gives us that distance there. So the gradient is defined to be y2 minus y1 divided by x2 minus x1. Does it matter which point you call x1, y1 and which point you call x2, y2? No, it doesn't, as long as you're consistent. So if I'm going to call that one y2 and that one y1, I must call that one x2 and that one x1. I can't mix x1 with y2. Let's have a look at a couple of examples. Finding the gradients of straight lines between given points. First example. Find the gradient of a line between 2, 5 and 7, 13. Well, what we'll do here is we'll treat this one as our x1, y1 and this one as x2, y2. So the gradient m is given by y2 minus y1, 13 minus 5, divided by x2 minus x1, 7 minus 2. 13 minus 5 is 8, 7 minus 2 is 5, so the line has gradient 8 over 5, 8 fifths. And we give it as an improper fraction. We don't want to be saying 1 3/5. Perhaps we could say 1.6, but normally we would leave it as an improper fraction. Second example, we'll take this to be x1, y1 and this to be x2, y2. So the gradient m is given by y2 minus y1, that's minus 5 minus 4, divided by x2 minus x1, 7 minus minus 3. Minus 5 minus 4 is minus 9. And 7 minus minus 3 is 7 plus 3, which is plus 10. Now minus divided by a plus is a minus, and so we get a gradient of minus 9/10. Moving on now, let's look at the distance between 2 points, x1, y1 and x2, y2. The same diagram, but this time we're just applying Pythagoras. If we want this distance, this length squared plus this length squared is equal to the hypotenuse squared. So we simply find d by taking the square root of this length squared plus this length squared. And that is shown in this formula here. The distance is the square root of the difference in the x-coordinate squared plus the difference in the y-coordinate squared. Two examples, same 2 points, so we'll have the d is the square root of the difference in the x-coordinate squared, that's 7 minus 2 squared, plus the difference in the y-coordinate squared, 13 minus 5 squared. So that's the square root of 7 minus 2 is 5, 5 squared is 25, plus 13 minus 5 is 8, and 8 squared is 64. 64 add 25 is 89, so d is the square root of 89. And this tends to come up on the Core 1 exam when you haven't got a calculator, so you would just leave it as root 89. Second example, the distance between these 2 points is the square root of the difference in the x-coordinate squared, so that's 7 minus minus 3 squared, plus the difference in the y-coordinate squared, minus 5 minus 4 squared. And the signs take care of themselves. If we've got a double negative, it becomes a positive. So d is equal to the square root of 7 minus minus 3 is 7 plus 3, which is 10. 10 squared is 100. Plus minus 5 minus 4 is minus 9. Minus 9 squared is plus 81. So we have 100 plus 81, which means that d is the square root of 181. Next we come on to look at the midpoint between points x1, y1 and x2, y2. Well, the midpoint, the x-coordinate, is simply the average of the x-coordinates x1 and x2. And the y-coordinate of m is simply the average of the y-coordinates y1 and y2. So m is x1 plus x2 divided by 2 for the x-coordinate and y1 plus y2 divided by 2 for the y-coordinate. Let's look at 2 examples. Again, the same pairs of points as the previous questions. Find the midpoint between 2, 5 and 7, 13. Well, m will be 2 plus 7 divided by 2 for the x-coordinate and 5 plus 13 divided by 2 for the y-coordinate. So m is the point 2 plus 7 is 9, 9 over 2. 5 plus 13 is 18, and 18 divided by 2 is 9. So we have 9 over 2, 9. Second example, m is the average of minus 3 and 7 for the x-coordinate. So let's add them together and half them. Minus 3 plus 7 divided by 2. And 4 add minus 5 divided by 2. Simplifying that, m is minus 3 plus 7 is 4. 4 divided by 2 is 2, so the x-coordinate is 2. 4 add minus 5 is 4 minus 5, which is minus 1. And minus 1 divided by 2 is minus a half. So the midpoint of those 2 points is 2 minus a half. Next we'll consider how do we recognize when 2 lines are parallel. Well, they're parallel if they have the same gradient. So if this one has gradient m1 and this one has gradient m2, if they're parallel, then m1 must be the same as m2. Let's have a look at some examples of parallel lines. Y equals 2x plus 3 and y equals 2x minus 7. These are parallel. This one cuts the y-axis at plus 3 and this one cuts the y-axis at minus 7. But they both have gradient 2, the number in front of the x, when we write the line in the standard form y equals mx plus c. Second example, y equals minus a third x minus 4, y equals minus a third x plus 1. The gradient in both cases is minus a third, so we instantly know that these lines are parallel. Something a little more difficult, perpendicular lines. Perpendicular lines have gradients that multiply to minus 1. So if there's a right angle between those 2 lines and this one has gradient m1 and this one has gradient m2, multiplying them together would give minus 1. That's the check. But in practice, to use it, if I divide this one through by m1, I'd get m2 is minus 1 over m1. So that's the easiest way to think of it, that the gradient of a perpendicular line is 1 over the gradient of the line it's perpendicular to, but with a different sign. 2 examples. Y equals 3x plus 4. If I want a perpendicular line, instead of a gradient 3, I want 1 over 3. But I also need a sign change. So if this one's plus 3, this has to be minus a third. If one line has a positive gradient, slopes from bottom left to top right, then the perpendicular line slopes the other way. And the second example, if we've got y equals 5 over 4x plus 1, a perpendicular line to that would be y equals minus 4/5 x, minus 3. The constants could be anything, but it's the gradient that's important. So what we're doing here, 1 over 5 over 4 is the same as 4/5. So to go 1 over a fraction, we just invert it. But you must always remember that you have a sign change. If you've got a negative gradient here, a perpendicular line will have a positive gradient. If you've got a positive gradient here, a perpendicular line to that will have a negative gradient. Well, we've now looked at the basic properties of straight line geometry, but we're now going to look at 2 very important techniques for finding equations of straight lines. And this first one is without doubt the most important equation in straight line geometry. We want to find the equation of a line with gradient m passing through a point x1, y1. So if we know the gradient of a line and any point on the line, we can find the equation of the line. Now I've marked on here 2 points on a line. One is the specific point, x1, y1, that it passes through, and the other one is what we call the general point. A general point on the line is denoted by x, y, where x and y can vary, so they are variables. Now let's have a look. Using what we know about the gradient is the difference in y's divided by the difference in x's. So I can write that the gradient m is equal to y minus y1, that distance there, divided by x minus x1, that distance there. Now all I need to do now is get this in a form that we can learn and put into practice. And all I'm going to do is multiply the equation through by this denominator. And we get y minus y1 is equal to m multiplied by this denominator. But I need to put it in a bracket because it's m is multiplied by the whole thing. And there it is, the most important equation in straight line geometry. We're now going to use it in a couple of examples. So the equation of the straight line passing through x1, y1 with gradient m is y minus y1 equals mx minus x1. So let's find the equation of the line with gradient 5 passing through 7, 4. Well, it's y minus y1 equals mx minus x1. And I would advise you to write it down like that every time you're going to use it. And then we start substituting in the numbers. So it's y minus 4, the y coordinate, is equal to the gradient 5 multiplied by x minus 7, the x coordinate. And now I'm just going to clear the brackets and get it in the form y equals mx plus c. So that's y minus 4 is equal to 5 times x is 5x, 5 times minus 7 is minus 35. Bring the 4 to the other side and we get y equals 5x minus 35 plus 4. Final answer, y equals 5x minus 35 plus 4 is minus 31. So there is the equation of the line. It has gradient 5 and it passes through the point 7, 4. Second example. Find the line with gradient minus a half passing through 4, 6. Start by writing down the equation of a line with gradient m passing through x1, y1. Y minus y1 equals m times x minus x1. Substitute in the numbers. Y minus the y coordinate is 6 is equal to the gradient minus a half multiplied by x minus the x coordinate is 4. Multiply out the bracket and we get y minus 6 is equal to minus a half times x is minus a half x. Minus a half times minus 4. A minus times a minus is a plus, and a half times 4 is 2. Bring this minus 6 to the other side and we get y equals minus a half x plus 2, and when the minus 6 comes across it becomes plus 6, to give a final answer of y equals minus a half x plus 8. So that has gradient minus a half and it passes through the point 4, 6. And we now come on to the last technique we're going to look at in this lesson, that of finding the equation of a line through two given points. So we're going to find the equation of a line passing through, say, x1, y1 and x2, y2. Well, I've begun here by marking 3 points on a line. 2 of them are the specific points that we're given, x1, y1 and x2, y2. And again, the third one is the general point on the line we call xy, where x and y can vary. And what I'm going to do is look at the gradient of this line in 2 different ways. So first of all, I'm going to consider the point xy and the point x1, y1 and look at the gradient. So the gradient m is given by the difference in the y coordinates, y minus y1, divided by the difference in the x coordinates, x minus x1. But now I'm going to consider the gradient by looking at these 2 points here. Now it's a straight line, the gradient is the same everywhere, so it's got to be the same as m. So the gradient of this will be the same as the gradient I've already found. And it'll be y2 minus y1 divided by x2 minus x1, the difference in the x's. And that's one form of the equation. But we try to put it in a form that we can remember. And to do that, I'm going to get all the y's to one side and all the x's to the other. So I'm going to divide this equation through by y2 minus y1, and it'll come down here. And I'm going to multiply the equation through by x minus x1, and that will go up there. So we end up with y minus y1 divided by y2 minus y1 is equal to x minus x1 divided by x2 minus x1. So let's look at what I've done there. I've multiplied this equation through by x minus x1, and the x minus x1's cancel on this side, but it gets multiplied in over here, and I've divided through by this numerator here, so it disappears on the right and appears in the denominator on the left. Now notice the patterns are the same in terms of y and x. Y minus y1 over y2 minus y1. X minus x1 over x2 minus x1. And in different textbooks you'll come across different variations of this, but the patterns are the same on either side. Now we'll put this into practice. We'll use this to find the equation of a line. And the example we're going to use is find the equation of a line passing through 3, 9 and 5, 13. So I begin by writing down the equation. Y minus y1 over y2 minus y1 equals x minus x1 over x2 minus x1. And this equation is not on the formula sheets in an A-level exam, you have to learn it. Now then, we'll call this one x1, y1, and we'll call this one x2, y2. So that gives me y minus y1, so it's y minus 9, divided by y2 minus y1, 13 minus 9. And that's equal to x minus x1, so it's x minus 3, divided by x2 minus x1, 5 minus 3. And now we can simplify the denominators, and we get y minus 9 over 13 minus 9 is 4. And that's equal to x minus 3 over 5 minus 3 is 2. And now I'm going to multiply the equation through by 4 to get rid of the denominator on the side of the y. So that's y minus 9 on the left hand side is equal to, and I need to multiply the right hand side by 4, put it in a bracket because I'm multiplying it all by 4, and I get y minus 9 is 4 bracket x minus 3 over 2. Let's just check what we're doing there. I'm just multiplying that through by 4, so the denominator disappears, but I have to multiply this side by 4 as well. Now the 4 and the 2 will cancel, so I can write y minus 9 is equal to 2 bracket x minus 3. And now we expand the bracket. Y minus 9 is equal to 2x, and 2 times minus 3 is minus 6. So y equals 2x minus 6. Take the minus 9 across, it becomes plus 9. And so y is equal to 2x, and minus 6 plus 9 is plus 3. So there's the final answer for the equation of the line. It's y equals 2x plus 3. Now there's a lot of algebra gone on there. Can we check it? Well, let's see. It's a straight line with gradient 2 and cuts the y-axis at plus 3, but does it pass through the 2 points? Let's substitute them in and find out. When x is 3, 2 3s is 6, plus 3 is 9, so the y-coordinate is 9. When x is 5, 2 5s is 10, plus 3 is 13, so y is 13. So that's reassuring that this line does actually pass through those 2 points, and we can be confident it's correct. Well, that brings us to the end of this introductory lesson on coordinate geometry. Let's consider what we've done. We first looked at some examples of straight lines using autograph. And then we looked at 2 points and we found the gradient of a line between 2 given points. We found the distance between 2 given points. And we found the midpoint between 2 given points. We then looked at the conditions on the gradient for 2 lines to be parallel and to be perpendicular. And then we went on to derive 2 important equations in straight line geometry. Y minus y1 equals mx minus x1, and y minus y1 over y2 minus y1 is equal to x minus x1 over x2 minus x1. And those have to be learned. And now you'll find an exercise that gives you practice with all the properties and techniques that we've covered.